Hello and welcome to another episode in recreating Baldur's Gate 3's camera inside Unreal Engine. In the last episode, what we managed to get sorted was collision with the walls. We no longer collide when we're moving through them, which is very nice. And we also got all these walls converted to our new environment actors and a subclass of them, BP_wall. And in this episode, we're going to start with the dithering I was talking about in the last episode. So faking transparency on large collection of objects all at the same time. And you might have seen as I was flying around here previously, I've got a house set up to demonstrate. So in the last episode, I used the example of being on the bottom floor. If I start moving my character in here, if we're on the bottom floor, we probably don't want the top floors being visible. We want to be able to have a clear sight onto what's on that floor instead of having all this in the way. So that's what we're going to get sorted now. And if I move the character up here, it would then start to fade in. So how do we do that? Let's get started. What I would recommend, by the way, is pausing the video now. And if you wanted to recreate this, just kind of set this up yourself. All this house is copied and scaled and duplicated, just environment walls that I've got set up. There's nothing fancy in here. It is all using, if I click on these pieces, they are all the BP walls we set up previously, other than the floor. The floor is just a standard cube that I dragged in with the basic shape material on it. So yeah, if you want to have a quick go setting up a little house, and we can jump into it. So what we're going to do is we are going to load up our material function that we've been using for the occlusion effect. So if we go to materials, MF environment mask, and full screen that, what we want to do is we want to add a separate branch completely to all of this that handles that dithering effect. Now, dithering is faking transparency, essentially. It's still using the masked logic of pixels are either 0, which is completely transparent, or 1, completely opaque, but it kind of shifts them around slightly, so you're able to see some of the pixels of the object wanting to be rendered, and some of them would be transparent. And it's going to be a lot easier to see what I mean when we get this set up. So let's dive right in. I'm going to hold down 1 and left click to bring in a scalar parameter. And we're actually going to convert it to a parameter by right-clicking Convert to Parameter. And we're going to call this Fade Amount. This value is going to control how transparent the object is in its entirety, so not including the occlusion at all. The fade amount, I am going to clamp in the slider min to 0, slider max to 1. And because we're going to be controlling this value in blueprints later on, which we'll get to later, I'm also going to clamp this just to make sure that we're not messing anything up outside of the material graph. So from there, what do we want to do? We want to drag that out into dither temporal AA. I think this is anti-aliasing. And what this does is this handles that dithering effect for us. We're just controlling that dither effect via this fade amount. By default, I'm going to put the fade amount to 1, so it's completely opaque just by default. And then I am going to do an if statement. So if I drag out and do if, and we're going to say if fade amount is compared to 1, if A is greater than 1, then we want to use just a value of 1. If it's equal, we'll use 1. And if it's less than, we will use that dither result. This might not be completely necessary, but I just like having it as a safety check. And what we can do is we can multiply the value of this by our occlusion effect and plug that straight into the shadow pass switch. If I apply and save this, it might take a minute to get the shaders compiled, but we should be able to see everything show up once again. What I'll do quickly is I will reduce the fade amount to 0.5 just to show you what this dithering effect looks like. Oh, you can see already it's got that, it's like rendering some pixels, but some of them are not being rendered. So if I adjust that slider, you'll see it fade out in its entirety. I'm doing this off screen. I'll drag that just so you can see what I'm doing. We've got the fade amount here, and I'm just adjusting that value. So between 0 and 1, it is faking a fade out because it's still rendering the pixels in its entirety. It's not trying to blend between this and the background. So it's making good use of processing power, I suppose. It's cutting down on the rendering cost very much so compared to normal translucency, which we can actually see if we go to optimization view modes, shader complexity, and let that build real quick. And if I start moving the fade amount around, you'll see everything is still remaining green, which is very nice when you're handling transparency, because it's very easy if you're using transparency to fall into the red and beyond into the white. So this is very cheap and very nice. So that's the effect. Now what we want to do is start controlling it via blueprints. So what we want to do is make the view mode back to lit, and we want to set up specific zones that will be affected by that dithering. And the way we're going to do that is we're going to make another blueprint and call it room collection. And the room collection is just a big old box that holds all the actors inside that are going to be affected whenever this effect happens. So if we go back into camera where all our blueprints are, we can right click, blueprint, actor, and we will call this room collection. I will prefix it with BP, load that up and drag that over. And we're going to add some logic in here that makes it a lot quicker to add environment pieces in. Some editor utility, which is very useful when you've got big scenes and you're trying to replicate this logic over and over. It's very good just to make those processes automated, and I can show you how here. So the first thing we're going to add in the components is a box collision. And this box is going to control the kind of the space from which everything gets affected, but it's also going to allow other characters and other kind of dynamic objects to enter the box and also be affected if need be. Like, for example, an NPC going up the stairs into a room that's out of view. So I'm going to do some just clean up here. Well, not clean up. I'm going to do some, what would you call it? Aesthetics. I'm going to just up the line thickness to 3, and the shape color we're going to make kind of a, what we want, like a pink. And the reason why we're doing this is if I drag this into the world now, it's just very obvious what this is. You know, you don't have anything else that looks like this. So you will know just by looking at it, that is the room collection. So the next thing that we want to do is we want to add a variable, 2 variables actually, and we're going to be making actor arrays, and we're going to call this one static objects and dynamic objects. I'm going to convert those to actors, and if we right click, oh, that didn't work, actor, and if we right click this now, it'll make it an array, and we'll do the same down here, actor. What's going on? Well, I did that out of order, but that's basically it. Compile and save, and what we want in the event graph is we want to make a custom event, and this is an event that we're going to be triggering ourselves in editor as opposed to an event that's triggered in game. So this is going to be gather actors, maybe, And if we click call in editor, compile and save, what you'll notice is that on the box we've dragged in, we now have a button called gather actors. Clicking it right now does nothing, but we can add logic to it. And the logic we want is we want to check everything that's inside this box we want to add to the static objects array. So to do that, we are going to drag off of gather actors and we're going to do a multi-box trace by channel. And we're going to get our box and get the world location. And the world location is going to be the start of the box trace. And the end of the box trace is going to be the exact same location, but slightly offset. So we can do add, and in the Z value, we're going to add like 0.01. So it's going to slightly trace up. The half height, we want to drag out from box again and do box extent. Get scaled box extent. That's an important distinction. Get scaled box extent will take into consideration the scale of the box or the actor, whereas unscaled box extent will get the literal values unscaled, and that can lead to problems. So use the scaled box extent here. And then we can drag out again, get rotation, get world rotation. In visibility channel, we can probably leave as visibility, and we will draw a debug for duration, just 5 seconds. Out hits, we're going to drag out and get a for each loop. So for everything that this is hitting, we want to check whether or not that's an actor that we want to fade in or out. So how do we check that? We first want to break that array element. So if we break that hit result, we can check the hit actor and see if it has that interface that we added previously. We can do implement, does implement interface. And in interface, we can select, what did we call it? Transparency, BPI transparency settings. And if it does have that, we can add a branch and add that hit actor to our static objects array. That's not what we want. We want to get the static objects and add the hit actor. Cool. So the difference that we have right now, or the difference between the static objects and the dynamic objects, our static objects are going to be all the objects that kind of just always exist in that area. For example, walls, tables, chairs, all the objects that aren't going to move out of that area. Dynamic objects are going to be the things that might be in the area or might not. Those are going to include characters, NPCs, maybe weapons that the character throws down, stuff like that. And so that's why we're only adding to the static objects. So this tool is just going to kind of figure out what's around this box and add it to a list automatically. What we are going to do as well is we're going to, at the start of this function, get the static objects and clear the array. Now, the reason why we're doing this is if we don't do it, if we leave it unhooked, if I compile and save right now, and if I don't know, I'll scale it up like this, just a little bit. And if I gather actors now, you'll be able to see nothing really because we haven't made this visible. So let's make static objects visible, compile and save. And now in the settings, we've got static objects down in the default tab. So if we hit gather actors, we can see some hit results going on, and it's added 8 array elements to our array. And if we click it again, it's doubled it up. It's 16 array elements, and it's not ever taking into consideration the fact that it's already got assets in those. So what we're going to do is we're just going to clear that every time and refresh it, basically. Compile and save. And now whenever we do it, gather actors, it's always going to be the same 8. And there you go. Those are kind of the ones that are being added. Now, the reason why we've got the box collision is A, to get the extent of the search for this gather actors, but it's also going to be what we use for dynamic actors, whether they're coming into the scene or out, but we're going to get into that a bit later. Now that we've got the room collection searching for these actors, we can set up specific zones. So let's drag this one down to the first level. And we want it to encompass everything that's down here. And if I get that lined up nicely, that should be good. I'm going to try and make it as tight as possible to the bounds of the area. Let's see. That looks good. I might also lower it down slightly. And I'm going to do the same for the second room. So I'm just going to copy and paste that, or duplicate it. I'm holding Alt and dragging that value, or not the value, dragging the pivot to duplicate it. And we're going to do the same again for the roof. So getting the roof assets. So now if we gather actors for each of these, you'll notice it fills in nicely. I'm going to search room so it's easier to select. Gather actors, and there we go. That has filled it up nicely with all the various assets that are in the room. You can see all those hit markers kind of indicating exactly where they are. And from here, we can now use these boxes to determine the dither extent. But this episode's already getting a bit long, so I'm going to move that into the next episode, and I will meet you there.